Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam October-November 2023, paper 43. Let's start it. Question 1. A list of substances shown. Answer the following questions using only the substances from the list. Give the name of the substance that, number 1, gives a lilac color in the flame test. Metal ions that give lilac color in the flame test are potassium ions, so the answer here will be potassium iodide. B. Forms a cream precipitate when its aqueous solution reacts with acidified aqueous silver nitrate. The cream precipitate here is silver bromide. So we will search for an aqueous solution that reacts with silver nitrate to form silver bromide. Of course, a solution must contain bromide ion. Here we have from the list sodium bromide. So sodium bromide will react with silver nitrate to form the precipitate silver bromide, which have a cream color, and of course sodium nitrate will be formed also. Here the answer will be sodium bromide. This is the aqueous solution that can react with silver nitrate to form a cream precipitated silver bromide. C. Acidic oxide. We know that non-metal oxides are acidic oxides, so the answer here is sulfur dioxide, which is unsaturated hydrocarbons. Unsaturated are alkenes. Alkenes contain double bond, so the answer here is propene. Which substance is a product of incomplete combustion of fossil fuel? We know that we have two types of combustion: complete combustion that produce carbon dioxide and water, and incomplete combustion that produce carbon monoxide, water, and particulates. So the answer here is carbon monoxide. The last one. Which substance is used to test for the presence of water? We can test for the presence of water using the anhydrous copper 2 sulfate or the anhydrous cobalt 2 chloride. Here we have in the list the anhydrous copper 2 sulfate. The color of the anhydrous copper sulfate is white. When we add water, the color changes to blue, and this indicates the presence of water. So the answer will be anhydrous copper 2 sulfate. Question 2. The table gives information about the particle from A to F. Give all the letters of all the particles which are atoms. Atoms are neutral, and that means that the number of electrons equal to the number of protons. So we will search for all the particles that have the same number of electrons and protons. We have here particle A, 5 electrons, 5 protons, so A is an atom. Then B, 10 electrons, 10 protons, also B is an atom. Finally F, 15 electrons and 15 protons. So A, B, and F are atoms. Which ion have the charge of -2? -2 means the number of electrons is higher than the proton by 2, or this particle have 2 more electrons than proton. We have particle D, 18 electrons and only 16 protons, so we have 2 more electrons. That means the charge is -2. Cation, that means the proton is higher than the electron. We have here particle C, 13 protons and only 10 electrons, so the particle C will be positively charged. It's a cation. State the atomic number of A. Atomic number is the number of protons, so the atomic number of A is 5 because it has 5 protons. Determine the number of nucleons in D. Number of nucleons are the sum of protons and nucleons in the particle D. So here in D we have 17 neutrons and 16 protons. The sum will be 33 nucleons. State the electronic configuration of D. D has 18 electrons, so they will be distributed as 2, 8, 8. This is the total of 18 electrons. The group number of F. The group number equal to the number of outer shell electrons. So we will go for F. F has 15 electrons. They will be distributed as 2, 8, F. The outer electrons are 5. So the number of the group is 5. F is in group 5. State the period number of B. The period number is the number of shells. So we will go to search for the number of shells for B. B has 10 electrons. They will be distributed as 2, 8. That means electrons are distributed in 2 shells. That means B is in period 2. The answer here will be 2. Question 3. This question is about nitrogen and some of its compounds. Nitrogen is converted into ammonia in the Haber process. Nitrogen is obtained from air. State the percentage of nitrogen in the clean dry air. Of course, it is 78%. State the source of hydrogen for the Haber process. We obtain hydrogen from the reaction of methane with steam. So the source of hydrogen will be from methane. It is the natural gas. Methane is a natural gas. Complete the dot and cross diagram for the molecule of ammonia. Show the outer electrons only. Here we have the nitrogen. Nitrogen have 5 outer shell electrons, so it will share 1 electron with each hydrogen atom. Now each hydrogen has 2 electrons, a complete outer shell. Then we will have a lone pair of electron for the nitrogen atom, because nitrogen has 5 electrons, 3 shared with 3 hydrogen atoms, and it still have a lone pair of electron in the outer shell. This is how to draw the cross and dot diagram for ammonia. Write a chemical equation for the reaction occurring in the Haber process and give the typical conditions, include units where appropriate. The chemical equation for the Haber process to obtain ammonia: 3 hydrogen molecules and 1 nitrogen to form 2 ammonia molecules. Here we have to write the equation balanced and with the reversible arrows. So 1 mark will be for the balanced equation and 1 mark for drawing the reversible arrows. Reaction conditions: the temperature 450 degrees Celsius, and the pressure we can either write 200 atmospheric pressure or 20,000 kilopascal, and the catalyst of course is iron or finely divided iron. B. Ammonia is converted into nitric acid. The first stage here of this conversion is to use a catalyst, and it happened at temperature 900 degrees Celsius and pressure of 5 atmospheric pressure. Knowing that the forward reaction is exothermic, ammonia reacts with oxygen to produce nitrogen monoxide and steam. Suggest which of the following element is most likely to be used as catalyst. Draw a circle around your answer. Of course, we will choose platinum because platinum is the only transition element in the list. And we know that transition element can be used as catalyst. State the oxidation number of nitrogen in ammonia. In ammonia, we have nitrogen and 3 hydrogens. Each hydrogen has an oxidation number of +1. So we will have 3 hydrogen. The total charge will be +3. So the nitrogen will balance the total charge of hydrogen. So the oxidation number of nitrogen will be -3. So as the total charge of the molecule will be 0. And for nitrogen monoxide, we know that the oxidation state of oxygen is -2. So for nitrogen to balance this negative charge, the oxidation number of nitrogen will be +2. So use your answer in double I to explain whether nitrogen in ammonia undergoes oxidation or reduction. The oxidation number of nitrogen here in ammonia was -3, and then change it to be +2 in nitrogen monoxide. That means the oxidation number increase from -3 to +2, and increase in the oxidation number, of course, is oxidation. So nitrogen have been oxidized due to increase in oxidation number. Your answer will be, of course, oxidation, because the oxidation number has increased. Complete the table using the words increases or decreases or no change. The table gives the effect of decreasing pressure, first on the equilibrium yield of nitrogen monoxide, then on the rate of the forward reaction. To know the effect of pressure, we have to count the number of moles on each side. Here on the left side, we have 4 plus 5, we have 9 molecules, and on the right side, we have 10 molecules. So of course, decreasing pressure will shift the position of equilibrium toward right, because the right has higher number of molecules. That will increase the equilibrium yield of nitrogen monoxide. So the answer here will be increase. Decreasing the pressure will increase the equilibrium yield of nitrogen monoxide. The effect of decreasing the pressure on the rate of reaction, of course, the rate of reaction will decrease by decreasing pressure, because decreasing the pressure, so we will have less number of particles per unit volume. The particle will have less frequent collision, and of course this will decrease the rate of reaction. Second, decreasing the temperature. We know that the forward reaction is exothermic, so by decreasing the temperature, the position of equilibrium will be shifted toward right, toward formation of more nitrogen monoxide, so the equilibrium yield of nitrogen monoxide will increase. Removing a catalyst. Catalyst has no effect on the equilibrium yield or the equilibrium position, so the removing catalyst will have no effect on the equilibrium yield, or we can write no change. Decreasing the temperature causes the rate of the forward reaction to decrease. Explain using the collision theory why the rate of reaction is slower at lower temperature. By decreasing the temperature, the kinetic energy of the particle decreases, so the particle will move slower, and hence we will have a less frequent collision. And decreasing the temperature, we will have lower number of particles that have energy equal to or more than the activation energy. Again, we will have less successful collision, and this will decrease the rate of reaction. In the second stage, nitric acid is produced. Balance a simple equation for this. To balance this equation, first we have 2 hydrogen here, so we'll start by adding 2 in front of nitric acid. Now we have 2 nitrogen, so we will add here 2 in front of nitrogen. Then let's count how many hydrogen we have here, oxygen. 2 multiplied by 3, 6. And here on the left side, we have 2 oxygen plus 2, 4 plus 1, 5. So oxygen is not balanced. We will try by doubling this number. Instead of 2, we will make it 4. Now we have 4 hydrogen, so we have to multiply here by 2. 2 times 2 is 4. And 4 nitrogen, so again we have to change this to 4. Let's count how many oxygen. On this side, we have 4 multiplied by 3, so we have 12 oxygen. On this side, we have 4 oxygen plus 2, 6, plus another 2 here, we have 8 oxygen. So if we can change this 8 to 12, the total equation will be balanced. We have 4 oxygen here in the nitrogen monoxide, plus 2 here, 6. So if we can make this also 6, now we have 12 oxygen. So if we multiply here by 3, now we have 4 plus 6, 10 plus 2, 12, and all the equation is balanced. 4 nitrogen monoxide plus 3 oxygen, 2 water molecule to form 4 nitric acid. Question 4. This question is about sulfuric acid and salts that are made from sulfuric acid. Zinc reacts with dilute sulfuric acid to form aqueous zinc sulfate. Powdered zinc is added to dilute sulfuric acid. In the mixture stirred, more zinc is added until the zinc is in excess. Then the mixture is filtered. Name the limiting reagent here, or the limiting reactant, because zinc is in excess, so the limiting reactant is dilute sulfuric acid. State 2 observations that indicate zinc in excess. We can note that zinc in excess when the sulfuric acid has finished, so no more fizzing of hydrogen gas, and the zinc solid stop dissolving and remain at the bottom of the beaker. Name the filtrate. Of course, the filtrate is the aqueous zinc sulfate solution. Name two compounds which both react with dilute sulfuric acid to produce aqueous zinc sulfate. Here, to prepare the zinc sulfate, we have too many options that we can use: zinc metal, zinc carbonate, zinc oxide, or zinc hydroxide. So here already in the experiment uses zinc metal, so we can use either zinc carbonate, zinc oxide, or zinc hydroxide. Zinc sulfate crystals are produced by heating aqueous zinc sulfate until the saturated solution forms. When the saturated solution cools down, the crystal of zinc sulfate start to form. First, state what is meant by the term saturated solution. Saturated solution is a solution that cannot dissolve any more solute at a given temperature. And here we have to mention a given temperature in the definition because we know that the solubility changes by changing temperature. Explain why the crystal form on the saturated solution when the saturated solution cools down, because by cooling the solubility will decrease. So we can write by cooling the solubility decrease, or the solubility decrease as the temperature decreases. C. Nickel sulfate crystals contain water of crystallization. When nickel 2 sulfate crystals are heated, they give off water, as we can see from the equation. The hydrated nickel sulfate give off water and form the anhydrous nickel sulfate. A student carries out an experiment to determine the value of X in the hydrated nickel sulfate crystal. First, he weighs the nickel sulfate, then the nickel sulfate crystal are heated. The remaining solid is allowed to cool and then weighed again. The remaining solid is heated and allowed to cool, then weighed, and he repeats the experiment until there is no change in mass. State the term used to describe the crystals that contain water of crystallization. As we've just mentioned, the crystal is called hydrated crystals. State why step 4 is repeated until there is no change in mass. We have to heat the crystal and wait, reheated and reweighed until there is no change in mass. That means the mass becomes constant to ensure that all the water has been removed and we only have the anhydrous nickel sulfate. Here in the experiment we have 0.454 grams of nickel sulfate crystal, the hydrated crystal. Then the remaining mass after heating is 0.31 grams. Of course, he gives you the MR for nickel sulfate and the MR for water. To determine the value of X, we will use the following steps. First, calculate the number of moles of nickel sulfate remaining, which is the anhydrous nickel sulfate. We have the mass of the anhydrous nickel sulfate, 0.31. We will divide it by the MR, which is 155, to get the number of moles of the nickel sulfate, the anhydrous nickel sulfate, which will be 0.002. Then, to calculate the mass of water given off, we will subtract the mass of the hydrated nickel sulfate minus the mass of the anhydrous nickel sulfate. So 0.454 minus 0.31 will be 0.144 grams. This is the mass of water. And to get the number of moles of water, we will divide the mass by the MR, which is 18. So we have 0.008 moles of water. Then to get the value of X, we will divide the number of moles of water by the number of moles of the anhydrous nickel sulfate. So we will have the value of X, which is 4. Question 5. This question is about iron. Describe the bonding in metallic elements such as iron. You may include a labeled diagram as a part of your answer. The bonding in iron, it is the attraction forces between the positive metal of the positive iron ions and the negative C of the localized electrons. We can label diagram here to write positive metal ions and negative C of delocalized electrons. Explain why iron conducts electricity when it is solid. Due to the presence of the delocalized electrons that can move through the structure. These delocalized electrons which can move can carry the current. Iron is extracted from hematite in the blast furnace as shown in the figure. Give 2 reasons why coke is added to the blast furnace. Here, coke has 2 functions. First, it reacts with oxygen, and this reaction is an exothermic reaction, so coke is a source of heat in the blast furnace due to the exothermic reaction, burning in the presence of oxygen. Second, coke acts as a reducing agent to reduce the iron 3 oxide. So these are the reasons, the 2 reasons for using coke in the blast furnace. Explain how limestone removes impurities in hematite. First, limestone decomposes by heat to form calcium oxide and carbon dioxide. Then, because calcium oxide is basic oxide, it will react with the acidic oxide silicon 4 oxide. This is a neutralization reaction to form calcium silicate. This is how the impurity is removed, because the impurities here is silicon 4 oxide. So calcium oxide react with the impurities to form calcium silicate, which is the slag that can be removed. Hematite contain iron oxide. Write a simple equation for the conversion of iron oxide to iron in the blast furnace. This is the main equation in the blast furnace, where iron 3 oxide is reduced by carbon monoxide to form iron and carbon dioxide. Of course, the equation is for 2 marks, so we have to balance the equation. Suggest why the iron produced in the blast furnace is molten. Of course, due to the high temperature in the blast furnace, the temperature of the furnace is higher than the melting point of iron, so iron is molten or a liquid when the temperature is higher than its melting point. Most iron is converted into steel, and steel is an alloy. Steel is more useful than the pure iron because it is harder and stronger. Explain why the structure of alloy causes them to be harder and stronger than the pure metal. You may include a diagram as a part of your answer. Here I draw a diagram for the alloy, which represent, here we have the iron atoms and the carbon atom to form steel, because steel is an alloy of iron and carbon. So what makes it harder and stronger than the pure metal? In the pure metal, the layer of the positive ions or the layer of the atom can slide over each other. But in the alloy, we have atoms of different sizes, as we can see from the diagram. So this disturbs the regular arrangement of the layers. So now the layers cannot slide over each other. So the alloy is harder and stronger than the original or the pure metal. Iron forms rust. Rust is prevented by coating iron with zinc. First, name the substance that reacts with iron to form rust. Of course, to form rust, iron reacts with oxygen and water. Name the process in which zinc is used to coat iron to prevent rusting. Coating iron with zinc is called galvanizing. Explain how the coating of zinc prevents rusting when the zinc is not scratched. When it is not scratched, that means the layer of the zinc is intact and iron is completely covered with zinc, so it is coated. That means zinc acts as a barrier which prevents oxygen and water from coming in contact with the iron. If the layer of zinc is scratched, so zinc here is act by another way, which we'll see in the second question. When zinc is scratched, iron becomes exposed of course to oxygen and water. Explain how zinc continue to prevent rusting even if the layer is scratched. So if the layer is scratched and the iron become exposed, iron will not react with oxygen because zinc is more reactive than iron. So zinc will react with oxygen. Zinc will oxidize and will lose electrons instead of iron, or more radially than iron, so iron will not rust. Question 6. Esters are members of homologous series of organic compounds. Give 2 characteristics that are the same for all the members of the homologous series. We have too many characteristics for homologous series. We can write any 2. They have the same general formula or the same function group. Ester X has a structure shown in the figure. Name ester X. To name the ester, we have to know the acid part and the alcohol part. The acid part is the part connected to the C double bond. So we have to count how many carbon in the acid part. Here 1, 2, 3. 3 parts, so it is propanoic acid. And here in the alcohol part, this is connected to the oxygen. 1, 2 carbons, so it's ethanol. The ester named ethyl propanoate comes from propanoic acid and ethanol. Ester Y has a structure formula, as we can see. Name the alcohol and the carboxylic acid used to make ester Y. Again, we'll make the same. The acid part is the part that's connected to the C double bond O, so we have only 1 carbon, so the acid is methanoic acid. And the alcohol part is the part that's connected to this oxygen. We have 1, 2, 3 carbons, so the alcohol is propane 1-ol. State the molecular formula of ester Y. The molecular formula, we have to count the number of carbon, hydrogen, and oxygen. We have 4 carbons, so it will be 4. How many hydrogens? 2, 4. That means 4 hydrogen plus 3, 7 plus 1 is 8, and 2 oxygen. This is the molecular formula of ester Y. Ester Z has a molecular formula of C4H8O2. State the empirical formula of the ester Z. The empirical formula is the simplest whole number ratio of the molecular formula. So we have to simplify this ratio by dividing by 2. 4 by 2 is 2. 8 by 4 is 8 by 2 is 4, and 2 by 2 is 2. So the empirical formula will be C2H4O. Polymers containing ester linkage are known as polyester. Polyamide are another type of polymers. And here he mentioned that nylon is a polyamide. We have the structure of nylon. As we can see, this is the amide linkage. State the term used to describe the type of polymerization used to produce polyesters and polyamide. The type of polymerization here, of course, is condensation polymerization, which is happened by removal of one molecule of water. Complete the figure to show the structure of the monomers that is used to produce nylon. Show all atoms and all the bonds. Here we have 2 monomers. The first one contain 2 carboxylic acid, one carboxylic group on each side, and the second monomer is this one, which contain 1 amino group on each side. We will draw the dark block with 2 carboxylic group, 1 from each side, and the white block with 2 amino group, 1 from each side. So here, this is the first monomer, and here is the second monomer, which is condensed by removing 1 molecule of water to form nylon. Naturally occurring polyamides are found in food. State the name given for naturally occurring polyamides. We have proteins, which is naturally polyamide occurring in our food. So it's natural. Name the type of monomers which is formed naturally occurring polyamide. The monomer, of course, is amino acids. Here we come to the end of our exam. Like the video and subscribe to the channel to receive all the updates. Comment down below if you have any question. Thank you for watching. Wish you all best of luck.